And welcome back, and it is the further maths for the 16th of May, 5 a day. Let's go with the first one. Right, what do we have? Straight line L1, straight line L2, L1 and 2 intersect, find A. This is your fairly straightforward simultaneous equation question, is it? So let's just write it out. So I've got 4x plus 2, and actually what I'm going to do, because I've noticed that y equals 7 minus x, is I'm just going to put this straight into here. So 7 minus x plus 1 is equal to 0. One equation, one unknown, I can solve it for x. Let's expand. So 4x plus 14 minus 2x plus 1 is equal to 0. Collect my x's, so 4x minus 2x is going to give me 2x. Collect my numbers, so 14 plus 1 is 15. Move it to the side is 15, which means that x is equal to minus 15 over 2. Again, I've got one easy equation to get my y. So my y is going to be 7. Well, I'm going to write that as 14 over 2 minus 15 over 2, which gives me 29 over 2. Yes, it does, which means my coordinates of A are going to be minus 15 over 2, or of course 7.5, and plus 29 over 2. And that's first question done. Next question. Using the digits below only once, how many 4-digit even numbers less than 5,000 can be made? Okay, so two key things here. So, well, actually three. 4 digits even and less than 5,000. Now, why I'm pausing is there's only one number that I can use that's less than 5,000. So that looks a little bit easier than I thought. Right, 1, 2, 3, 4. So this can only be a 1, which means there's only one choice there. And then because it's even, it can be an 8 or a 6. Okay, again, I'm pausing because there's two 7s here. That's going to make this question quite hard. Let me come back to that. So I've got an 8 or a 6. So there's two choices here, which are 8 and 6. So there's two choices there. So far, there hasn't been a huge amount going on, has there? Now, if I've chosen, let's say 6. It doesn't matter if it's 8 or 6. But let's say I've chosen a 6. Then there's 1, 2, 3 numbers left to choose from if we consider the 7s as a single number for now. And I'll come back to the double. So therefore, there's 1, 2, 3 numbers to choose from there. So multiplied by 3 here and 2 here. And then if I multiply this one out, so that's going to be, actually, sorry, let's be consistent. Let's put my 3 and my 2 here, get rid of it from here. So if I multiply that out, that's 1 times 3 times 2 times 2, which is 12 numbers. Now, I've got to deal with this problem here. I've assumed when I'm choosing my numbers that I can only choose one 7. Let's think about the case where I could choose two 7s. Well, there's only two places it can go. You can only go in the middle, or I should say there's only one place it can go, which is in the middle, where 7 is the same as 7, so it doesn't matter if I've switched them around. And there's either an 8 there or there's a 6 there because that number's fixed. So there's two ways of doing this, 1, 7, 7, 8, 1, 7, 7, 6. So there's a further two measures, which gives me a total of 14 combinations. That's a really quite difficult question. Next question. The first two terms in a linear, okay, linear keyword again. You'll notice I'm underlining or highlighting some of these keywords. Are this here? What's the fourth term? Well, because it's linear, my difference is consistent. So my difference is always root 6 minus the first term, which is minus 2 minus 3 root 6, which is the same as minus 2 minus 2 root 6. That's not very nice, is it? And then the fourth term. So the fourth term, well, if you think about it, so the first term is A. Second term I had 1D, the third term I had 2Ds, and the fourth term I had 3Ds. And so therefore my fourth term is going to be my first term, 2 plus 3 root 6. And then I'm adding on 3Ds, so that's minus 3, because I'm taking the minus here, of 2 plus 2 root 6, or 3 times minus 2 root 6. Let's collect this. So I've got 2 minus 2 times 3, which is minus 4. And then on the root 6s, I've got 3 root 6s here, and then I'm taking away 6 of them, so that gives me minus 3 root 6. And that is my final answer. Next question. Show that f of x is increasing. Well, we've done a few of these if you watch my videos elsewhere. So the first step, increasing functions are specifically where f of x is greater than 0. So I can reread this question as, is the first derivative greater than, and we won't use this, we'll use a strict inequality, where the strict inequality is greater than 0. It doesn't matter whether you equal 0 or not. It's a bit of a mathematical argument. You don't need to worry about that. So let's first differentiate. So therefore, f of x is going to give me 6x squared minus 4x plus 30. And I want to show that is always greater than 0. Now, the easiest way of doing this is to find where the vertex is. So I'm going to complete the square. This isn't a nice one at all, but we'll give it a go. So it's going to be 6x squared minus 4 over 6 is 2 over 3x. And then I'm just going to leave this 30 out here by itself. Then complete the square inside. That's going to be x minus a third, half of 2/3 is the third, all squared minus a ninth plus 30. And then that's going to give me 6x minus a third squared. 6 times minus a ninth is minus 2/3, as in 6 over 3, and that simplifies down to 2/3. Take that away from 30, and that's going to give me, now I don't normally write this, but I'm going to write it this way because it doesn't really matter. That's going to give me 29 and a third. And then I actually need to make a clear argument that that is greater than 0 for all values of x. And this is greater than 0. So therefore, and I've explained it, the examiner will know what to look for here. So therefore I can say f of x, answer the question, is increasing for all x. Question done. Next and final question. The coefficient of the x cubed term in a to the 5. So let's remember our Pascal's triangle is 1, 5, 10, 10, 5, 1. I'm going to say this is my, x. This is my x to the 0. This is my x to the 1. This is my x to the 2. And this is my x to the 3, which is the one that I want. So therefore the coefficient is the 10 with the combinations number multiplied by 2x cubed. I'm going to include the x and then take it away. And then multiply that by a squared, because 5 minus 3 is 2, so it's a squared. And I know that's equal to 2,000. Then I'm going to just basically tidy this up a little bit. So 2 cubed is 8. So that's going to give me 80x cubed times a squared is equal to 2000x cubed. And then I'm going to get rid of the x cubes. Obviously in an exam you can't just delete them like I can. Then I'm going to divide by 80, which tells me that. Now at this stage I'm basically going to hope for a nice number. So calculator out, and that tells me that a squared is 25. And therefore a, well I don't know whether it's plus or minus, so both answers are valid. So therefore a is plus minus 5. And that's my final answer. Quick check, it says find the possible values of a. So there's definitely 2, and I'm happy those are they. And that's it. Questions done today. Good question today. I quite enjoyed today again. Let me know how it went for you, and I will talk to you more. Thanks all.